Hi, I'm Blake Margolis.
Hi, I'm Dillon Heinen.
Hi, I'm Worthington.
My name is David Janosky.
So at a high level, our team created a robotic hand powered by servo motors and controlled by slide potentiometers over Wi-Fi. This video is comprised of two segments which were recorded about a week apart. In the first segment, Dillon and Blake will walk y'all through the controls and basic functionality of our robotic hand. And in the second segment, Blake will demonstrate the hand as it's controlled wirelessly between two boards with ESP8266 Wi-Fi modules.
This is our final project for Embedded Systems EE445L under Dr. Mark McDermott. And what we've done here is we've created a hand that can be controlled by some potentiometers and can actually perform pre-made gestures. We did this by using a 3D printed hand and essentially running wire through it, wire that would allow us to control those gestures with a servo motor. And the servo motor and everything is essentially housed in here. The wiring and assembly for the actual hand itself is housed in here, and the potentiometers that are controlling the hand's movement are right here. This box under here is just to allow the power cord to reach for now, and isn't actually part of the unit. But essentially what we're able to do is just control each hand, or each finger on the hand rather, with these potentiometers. It responds to specific gestures that we want to give it. Right now we're using these potentiometers to control the actual fingers themselves individually and creating our gestures, but we've also explored software routines where you can essentially pick a gesture and it automatically makes it by sending a precise amount of sending a signal to the servos to control the individual servos that control the fingers. Basically that's how this works. Our TM4C is sending PWM signals to the servo, and then the servo is going to be controlling the finger. And basically we're just going to move this around and we're going to see how that affects the hand itself. And I'm just wiggling the pinky with this one servo right here, or with this one potentiometer rather. And we have full control of all of these fingers, so I'm just going to run through them all just to sort of verify the functionality. We have our index finger. We have our thumb. And you can do all kinds of fun stuff with this. Let's do the UT hook'em sign. Do the OK symbol right here. What else can we do? Well, I can think of some other things that maybe wouldn't be.
Pinky's up.
Yeah, exactly. Let's do pinky up. I like that idea. Very fancy. Very fancy indeed. But yeah, you can just control this in a variety of ways. And considering that maybe we weren't as constrained as far as budget and stuff, there's a lot of ways that you can take this. Specifically, we explored using flex sensors on the hand to control it from your actual hand itself and matching those movements. And with minimal modification, we could create something similar to that. Here we have a network of strings that are running through the fingers that are connected to the servos, and that's basically our main method of control. It's very interesting. I don't know if you want to get more information on it.
Yeah, and the hand itself is 3D printed from ABS plastic, and then the hinges are a flexible filament. This is a bit of a casual update. We were working on this over the weekend and added a couple features. These are our sliders for the fingers of our robotic hand. This is the Wi-Fi module, ESP8266, and our Launchpad Tiva C microcontroller. Over here is our hand setup. This hand is printed from ABS plastic, and the hinges are made from this TPU filament. This is our custom-made PCB, again with the ESP8266 the Wi-Fi card. And underneath is actually our Tiva C microcontroller. This one is surface mounted to the bottom of our PCB. So now we're going to move a finger. There is a bit of a network delay, so it does take a bit. There we go. Then let's actuate a few more fingers. Oh, that's unfortunate.